Come with me on a journey, far from home, past Mars and Jupiter to Saturn's realm. Among Saturn's many moons orbits a small world with immense potential, Enceladus. Only about 500 kilometers across, you could fit it within Arizona. Discovered in 1789 by William Herschel, Enceladus was long just a faint point of light, its secrets hidden. But even from afar, it stood out as the most reflective object in our solar system, shining with a pure white light. Its surface is a blanket of fresh, clean ice, reflecting nearly all sunlight and plunging temperatures to -200 degrees Celsius. At first glance, it seems frozen and lifeless, but looks can be deceiving. Enceladus orbits within Saturn's faint E-ring, and for decades, astronomers wondered what was replenishing it. The prime suspect, Enceladus, perfectly positioned in the ring's center. But how could a tiny, frozen moon be geologically active enough to spray material into space? The answer would transform Enceladus from a curiosity into one of the most compelling destinations in the solar system. It challenges our old ideas of habitability, showing that life's ingredients might exist far from the sun, powered by planetary forces. Enceladus shatters the notion that only planets in the Goldilocks zone can host life. Here, in the cold depths of the outer solar system, a tiny moon may hold the key to life's possibilities. The story of Enceladus is a testament to our relentless curiosity. Our first close look at Enceladus came in the early 1980s, when Voyager 2 flew past Saturn. Its images revealed a surface both smooth and cratered, a mix of young and ancient terrain. This hinted at geologic activity, but Voyager's brief visit left us with more questions than answers. 2 decades later, Cassini arrived at Saturn, equipped to study its moons in detail. Enceladus was a prime target. Cassini's instruments detected something odd. Saturn's magnetic field was being disturbed around Enceladus, suggesting a local atmosphere. A moon this small shouldn't have an atmosphere. Something had to be venting gas from within. The clues pointed to an astonishing conclusion. Mission controllers sent Cassini closer, flying just a few hundred kilometers above the South Pole. There, Cassini flew through gigantic plumes of water ice and vapor erupting from the surface, shooting hundreds of kilometers into space. These weren't small geysers, they were colossal jets like a cosmic sprinkler system. The mystery of the E-ring was solved. Enceladus was its source. This tiny frozen moon was alive, venting material into space. Cassini's discovery transformed Enceladus into a world of active geology and immense intrigue. Suddenly, it was a place where the search for life became real. The plumes were a direct invitation to explore further. Enceladus was no longer silent, it was crying out into space, and we were finally there to listen. The stage was set for a new era of discovery. The source of the plumes? 4 long, parallel cracks at the South Pole, nicknamed tiger stripes. These fissures, named after cities from Arabian Nights, are the hottest spots on Enceladus. While most of the moon is -200 degrees Celsius, the tiger stripes are a balmy -90. Heat leaks from within, and these cracks vent the plumes. Cassini sampled the erupting material, revealing it was 98% water vapor. But the remaining 2% was even more intriguing: methane, propane, carbon dioxide, nitrogen, and complex organics, the building blocks of life. Deep beneath the ice, there's liquid water, heat, and organic chemistry, the 3 essentials for life. On Earth, wherever there's water, there's life even in the harshest environments. The plumes are like free samples, offering a taste of a hidden ocean without drilling. This discovery elevated Enceladus to a prime candidate in the search for extraterrestrial life. Suddenly, the focus wasn't just on Mars or distant exoplanets, it was right here on a tiny moon of Saturn. The tiger stripes are more than geological features, they're windows into a potentially habitable world. They beckon us to explore a vast, hidden ocean that could be teeming with life. Enceladus became a game-changer in our search for life. The evidence was mounting and the mystery deepened. The next step, understanding what powers this hidden ocean. How can a tiny, distant moon have a liquid ocean? The answer: gravity's relentless pull. Enceladus is locked in a gravitational dance with Saturn and the moon Dione, creating tidal forces that flex and heat its interior. This tidal heating is like bending a paperclip until it's warm, except on a planetary scale. The result: enough internal heat to maintain a global ocean beneath the ice. This discovery redefined habitability. Not just proximity to a star, but internal energy can create life-friendly environments. Cassini's data showed the ice shell isn't frozen solid to the core, it floats atop a vast ocean, possibly tens of kilometers deep. This ocean may contain more water than all of Earth's oceans combined, Internal heat likely drives geological activity on the seafloor. At the boundary between rock and water, there could be hydrothermal vents, like those on Earth's ocean floors. On our planet, these vents are oases of life thriving without sunlight. Could the same be happening on Enceladus? The evidence points to a dynamic, active world beneath the ice. The possibility of life grows stronger with every discovery. The next question, what's in that ocean? The plumes of Enceladus are a direct line to its hidden ocean. Cassini, acting as a cosmic chemist, analyzed their composition. Beyond water and simple organics, it found molecular hydrogen, a key food source for microbes on Earth. This suggests chemical reactions between hot rock and ocean water, just like at Earth's hydrothermal vents. Enceladus's ocean is dynamic and chemically active, with a steady supply of energy. The ocean is moderately alkaline, salty, and surprisingly Earth-like. Cassini also detected tiny grains of silica, which form only in hot water, evidence for active hydrothermal vents. These particles travel from the core ocean boundary through the ocean and erupt into space. For years, one ingredient was missing: phosphorus, vital for DNA and cell membranes. Recently, scientists found clear evidence of phosphates in the plume material. Now, Enceladus's ocean appears to have all the essential ingredients for life: water, energy, and the key chemical building blocks. The pieces of the puzzle are coming together. Enceladus is more than just an icy moon. It's a world with real potential for life. The search for life has a new promising target. The next step: new eyes and new missions. Cassini's mission ended in 2017, but our exploration of Enceladus continues. The James Webb Space Telescope, though not a spacecraft, has turned its powerful gaze toward Enceladus. JWS observed a water vapor plume erupting from the South Pole, far larger than anything Cassini saw. This plume stretched over 9,600 kilometers into space, nearly 20 times the moon's diameter. The rate of water ejection is immense, enough to fill an Olympic pool in hours. This discovery confirms Enceladus is even more active than we thought. A plume this large means future missions could sample it without flying dangerously close to the surface. JWST's observations bridge the Cassini era and the future of Enceladus exploration. They show us there's still much to learn, even from afar. The mystery of Enceladus grows deeper, and our desire to return intensifies. The moon is actively advertising its potential for life, spraying evidence across the solar system. The call of Enceladus is louder than ever. The next chapter is about to begin. What's next? Enceladus is now the most promising place in our solar system to search for present-day life. The evidence is overwhelming: a global ocean, internal heat, complex organics, and all the key elements for life. The next step is clear. We must return, this time with instruments designed to answer the ultimate question: is there life in that ocean? NASA and ESA are planning missions to orbit Saturn and make targeted fly-throughs of the plumes. The proposed Enceladus Orbolander would sample the plumes, then land near a tiger stripe to analyze fresh snow. The challenges are immense. Instruments must be exquisitely sensitive, and planetary protection is paramount. We must avoid contaminating this pristine world with Earth microbes. But the potential reward is worth it. Discovering life on Enceladus, even microbes, would change everything. It would mean life is a common cosmic phenomenon, not unique to Earth. Enceladus represents a turning point in our cosmic story. Its secrets are locked beneath the ice, waiting for us to return. The journey continues.